Introduction to Electric Charge Theory. It is really important to understand the concept of electric charge, voltage, current, and resistance. These concepts are vital in the design, manufacture, and when using the electrical components and devices. The components play a big part in our day-to-day life, from work, to the car, to even in the kitchen. To understand charge, let's go back to basics, such as physics and chemistry. So, you can see on the screen a model of the helium atom. In the center, there is a cluster of protons and neutrons. This is called the nucleus of an atom. Protons are positively charged, and neutrons, as the name suggests, are neutral. They carry no charge. Surrounding the nucleus is a cloud of electrons. In this case, there are 2 electrons, and those electrons are attracted to the nucleus. This attraction is because the electrons have a negative charge, whilst the protons have a positive charge. In chemistry, elements are typically described, like in the periodic table, by their atomic number and mass number. In this case of helium atom, the atomic number is 2, which means there are 2 protons and the mass number is 4. And this is the total number of protons and neutrons in an atomic nucleus. The mass number is approximately equal to the atomic mass of the atom, which is the number of protons and neutrons in an atomic nucleus. Helium element is electrically neutral, and that is because there are same number of electrons as protons. So, let's have a look at an atom that is more useful for electronics. And what you can see on the screen is a representation of the copper atom. In this case, we have 29 protons in the nucleus. The nucleus is surrounded by shells of electrons. And the closer these shells are to the nucleus, the tighter they are bound by stronger electric charge. So these bands, or shells, fill up with a large number of electrons. What we are most interested in is the outermost shell, and that is called the valence shell or the valence band. Basically, if we have one or few electrons in the valence shell, it is possible these electrons can move into higher energy state and not be bound to the atom. In most cases, it is the number of electrons in this outermost shell that determines how chemically active atom is. Categories of materials. Because of the different number of electrons that can occupy the valence band, we can actually arrive at different categories of materials. We have conductors, insulators, and semiconductors. Conductors are materials where there are electrons that can drift in the presence of electric field through the material. So, they only have 1 to 3 electrons in the valence shell, and those electrons are not tightly bound to the nucleus and can easily break free. Insulators. Insulators have more than 4 valence electrons, and these are more tightly bound to the atom, and therefore you do not have many free electrons in an insulating material, and they do not conduct electricity or not very well. We do have something in between, and we call them semiconductors. They are really important for electronics. They have 4 electrons in the valence shell. In addition, we can manipulate this number by doping with impurities, so we can go to 5 or even 6 electrons, or down to 3 or even 2. And this changes the overall properties of the material and become N-type or P-type. Electric charge. Electric charge is a physical property of matter. Electric charge can be positive or negative, commonly carried by protons and electrons respectively. Like charges repel each other, and unlike charges attract each other. An object with an absence of net charge is referred to as neutral. The SI-derived unit of electric charge is the coulomb, where 1 coulomb is the total charge found in 6.25 multiplied by 10 to the power of 18 electrons. If we take the reciprocal of that number, we can find the charge of 1 electron, which is 1.6 times 10 to the power of minus 19 coulomb. Electric field. An electric field is an invisible force field caused by an electric charge. It is an alteration in the space, air or vacuum around the charge. It results in an electric force that is felt by the electric charges when placed close to one another. A static electric field is created when the charges are stationary, and the corresponding force is known as electrostatic force. The electric field is a vector quantity having both magnitude and direction. By convention, we can show lines emerging from the positive charge, and for negative charge they are drawn in towards the negative charge. So, if we have charged surfaces where the top surface has an abundance of positive charge and the bottom surface or plate possesses a negative charge, we can draw lines of force between the two oppositely charged surfaces. And what we have is an electric field. So, the force acting between the charges is called an electric field.